Now we're going to look at solving radical equations or equations that have a radical in them. In our case, it's mostly going to be square root. You're not going to have to worry about things like cube root or fourth root or anything like that. But the process is still the same. Especially for radical equations, we're going to assume we're talking about square root of x. So something like solve the square root of x minus 8 equals 0. We need to know what order to deal with things. We need to know if there's anything special to worry about. The key really is just similar to when we were doing inverses. Isolate the radical. Okay, we want to get that part by itself first, and that makes our equation a lot simpler to deal with. And then once we've isolated the radical, we want to make sure that what it's equal to is positive. So we've got a positive result. Because if you think about it, what that means is if I take the square root of x and set that equal to -4. Now we're asking for what number do I plug in here that when I take the square root of it, it guarantees me a negative answer. There's no way for that to happen as it is, and at this point we know that there's no solution. Not going to deal with a whole bunch of those up first, but as we move on, that's going to be something you're going to want to definitely double check. So let's work some examples. I want to solve the square root of x minus 4 equals 0. So I want to know what number do I plug in here, take the square root of it, and then subtract 4, I get 0. Well, if I need the square root of x to be by itself, I move the 4 by adding it. The square root of x equals 4. Square both sides to clear the radical. And I've got x equals 4 squared, which is 16. Simple enough, right? Okay, so how are things different if I've got 2 times the square root of x plus 4 equal to 0? I still need to isolate this radical quantity. Well, the way I'm going to do that, just like with inverses, we're going to divide by 2, which is really handy because 0 divided by 2 is still 0. The square root of x plus 4 is now by itself, so we're ready to square both sides. Again, yay for 0 and x plus 4. When I subtract 4 from both sides, I've got x equals -4. Seems kind of fishy, because I know I can't take the square root of a negative number, right? It becomes imaginary. But is it okay to plug in a -4 into this radical? So we're going to ignore everything else and just go back and think, okay, square root of -4 plus 4. Is that an okay step to take? Well, square root of 0 just equals 0. Everything's okay. So I'm going to keep that -4 as my solution. Couple more. 3 times the quantity x minus 1 to the 1/2 power equals 15. Raised to the 1/2, remember, is the same thing as taking the square root. It's just a different way of writing it down. Either way, I've got parentheses and an exponent. I need to isolate that before we worry about what it means. Divide everything by 3. And that leaves x minus 1 raised to the 1/2 is equal to 5. I can rewrite it with a radical, or I can just go ahead and raise the whole thing to the 2nd power, because that's going to cancel that exponent. 5 squared is 25. Add 1, and x equals 26. Last one we're going to do together looks worse, but it really might be one of the simpler options. What if I've got a radical, 3x plus 6, equal to another radical, 7x plus 10? Now it's going to be tempting to subtract one of those and move them over to the other one, but as it sits right now, they're both isolated on their own side. And I'm going to use the same operation to clear them. So when I square both sides, they're both going to fall out. And I'm left with 3x plus 6 equal to 7x plus 10. And it's just a real simple linear solving. I'm going to move the 3x this way. 6 equals 4x plus 10 minus 10. Negative 4 equals 4x. And x equals negative 1. Again, that might make us a little nervous. We go back. If we double check, can I plug in a negative 1 here and still have a positive result? 3 times negative 1 is negative 3, plus 6, it's more than 0. 7 times negative 1 is negative 7, plus 10, again, it's more than 0. So we're okay to keep that one.